Hello and welcome to this third tutorial about the Blueberry 4. Today we're going to look at subtraction. Now if you have watched the second tutorial about addition, you will already be familiar with the basic concepts of adding two binary numbers. What we do today is we add an additional module to our setup, and this is this one here, the inverter. It's the second yellow module, and inverter is written at the top. We will see what it does in just a moment. What we start with is we wire up our setup as yesterday, and for example today I start with the data wires. Data from the first manual programmer is going to the adder, and the data from the second manual programmer, and that's different to the setup we had in the second tutorial, is going here into the inverter. All right, so that's the number we want to subtract. See this here, this left manual programmer goes right into the adder, into the left port, and the right manual programmer first goes into the inverter, and then from the inverter to the adder. And as before, then because we want also to see the decimal output, we feed this into the decimal display. All right, what's missing is power. So we connect the little power cables from the program counter to the manual programmer, from the program counter, in this case, to the inverter. See them all light up, that's nice. And from the program counter to the second manual programmer. Now we just need to wire up two more modules. Which is the adder. And finally we connect the power wire from the adder to the decimal display. Right, okay, that's active now. So we've wired up power and data, and we can now, as before, as in the second tutorial about adding, we can set binary data here and binary data there. Right, it's not subtracting, is it? 1 plus 1 is still 2, and 2 plus 1 is still 3. We would expect some kind of minus happening here, but it's not. Why is that? Well, the inverter is not active yet. It needs an activation signal, and for that we need to add two wires, and we take two of the 1-pin wires, and one of them we run from the inverter, any of these two little pins here, to the adder. All right. Is it subtracting? No, it still isn't. 2 plus 1 is still 3, so that wire was not enough. But this little wire here, this little 1-pin wire, goes anywhere to plus 5 volt. So plus 5 volt you will find, for example, here on the manual programmer, the left little pin, and I just plug this in. And something has happened. 2 minus 1 is now 1. See if that's just a coincidence. We run another experiment. Let's say 4. That's a 4. 4 minus 2 is 2. So it seems to be subtracting quite reliably. Let's try another one. 4 minus 1, 4 minus 3. 4 minus 3 is 1. So something is happening here. What's happening? You see this data piece here, a 0, 0, 1, 1, going through the inverter when it's subtracting is doing something with it. It's turning it into a 1, 1, 0, 0. Okay, so it looks like an opposite. If we put another pattern in, 0, 1, 0, 0 is somehow being converted into a 1, 0, 1, 1. Let's try another one. In case we have an 8, 8 minus 7 here's our 7, and 8 minus 7 is 1. And again, the inverter produces the opposite. So a 0, 1, 1, 1 turns into a 1, 0, 0, 0. All right, so that's interesting. So the inverter seems to be doing inversion, hence the name, and then it is feeding the result into the adder. The question is, what is this wire doing here? So we seem to understand that this wire here is activating the inverter, this green wire. But what is this blue wire doing? Well, in order to find out, we might just as well disconnect it for just a moment and see what's happening. All right, 0. So we are 1 short now. So 8 minus 7 now is 0. And if we connect the wire again, it is 1, which is correct, and 0 is incorrect. See if that's always the case. So let's say we do 15. 15 minus 8 without the wire connected is 6, and with the wire connected is 7, which is of course the correct result. Another experiment, because you can never be sure whether things are reliable or not. Let's do something else. This is a 5, and a 5 minus a 4 is 0, and with the wire plugged in it is 1. So this wire seems to have some kind of +1 function. It looks like it is sending this +5 volt signal to the adder so that the adder knows that it has to do a +1. It's like a carry in into the addition. All right, so it looks like with our experiment we have found that we can do subtraction, and for that we need an inverter which builds the opposites of numbers. We call this the binary complement, and then we need to tell the adder that it has to add a 1 to the result in order to get the correct answer. And why this is the case, we look at in just one moment. Okay, so let's have a look at binary subtraction on the good old sheet of paper. And we have learned about the binary complement before in the experiment. So let's say we want to do a subtraction. We want to do, let's say 8. That's an 8 in binary. Okay, it's an 8. And we want to subtract 7. And a 7 in binary is 1, 1, 1. Okay, here's the 7. And we already know that 8 minus 7 is 1. But computers can't subtract without the inverter. So the inverter needs to do its magic. We need to reduce a subtraction to an addition. And the way we do this is we take our 8. Oh, here it is. And instead of subtracting, we want to add the binary complement. Now the binary complement is easy. We just simply turn all the 1s into 0s and 0s into 1s. So this is here 0, so that becomes a 1, and a 0, and a 0, and a 0. And remember, we need to add 1 later, but we park that for the moment. So 1, 0, 0, 0 plus 1, 0, 0, 0. What is that? Well, that is a 0, that's a 0, that's a 0, that's a 0, and that's a 1. Okay, so that's actually 16. Now, we also have to add this little 1. We shouldn't forget this. This little wire adds the 1 to it, and we get the following result, 1, 0, 0, 0, 1. Now, our Blueberry 4 is a 4-bit computer. That means it can only represent 4 digits. This one, this one, this one, and this one. Okay, it cannot represent this digit here on the left, which means we can simply cut this off. And the result is indeed 1. Decimal 1. Now, maybe just all a coincidence. Let's use another example. Let's do, let's say 4 minus 3. 4 minus 3. And we know that the result hopefully is 1. So 4 in binary is 0, 1, 0, 0. Minus 3, which is 1, 1. And we turn this over here, and we turn this into an addition of 0, 1, 0, 0, plus the binary complement of 3 is 1, 1, 0, 0. Okay, so we can add now. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 1 is 1, carry over 1. And 1 plus 1 is, apologies, 1 plus 1 is 0, carry over 1. And 1 plus 1 is 0, carry over 1. We shall not forget the plus 1, which we'll do now. Plus 1, okay. So the result is 1, 0, 0, 0, 1. All right, again, the Blueberry 4 is a 4-bit computer, so we forget this bit here, and the result is 1. All right, looks so far we seem to have gone with examples that always produce a 1 as a result. So let's do something else then to see if it's true what we're doing here. Let's say I want to do 7 minus 4. 7 minus 4 is 1, 1, 1. Minus 4. And of course we know that the result should be 3. We now build the binary complement of the second number. So that is 1, 1, 1. That stays the same. Plus the binary complement of this number is 1, 0, 1, 1. Okay. And then we add these numbers together. So 1 plus 1, 0 carry over 1. 1 plus 1 plus 1 is 1 carry over 1. 1 plus 1 is 0 carry over 1. And 1 plus 1 is 0 carry over 1. We then do the plus 1. And with that we receive a 1, 1, 0, 0, 1. Blueberry 4 being a 4-bit computer can't represent the 5th bit, so here, let's forget. And the result is 0, 0, 1, 1, and that of course is a 3. So it looks like we have found a reliable way to do subtraction by building the binary complement of a number, adding it, adding a 1 to the result, and chopping off the 5th bit. And with that, we have successfully mastered binary subtraction. There are videos on YouTube about 9's complement and 10's complement, which you may want to watch, which are useful to understand how this concept is applied to the decimal system, where it has also been used in the past for mechanical adding machines. Not so much used today anymore, but certainly the binary complement is used every day in our computers. So thanks for watching. I hope you now have a better understanding of how a computer subtracts. And with that, you have pretty much mastered the arithmetic logical unit of our little Blueberry 4, consisting of the adder and the inverter. Thanks for watching. Hope you liked it. If you've got any comments, please put them in the comments field under this video, and I will respond as soon as I can. Thanks very much.